Hello students, welcome to the class of Control System Engineering. I am Priyantini Mukherjee, Assistant Professor of Electrical Engineering Department of Narula Institute of Technology. In this class, we will discuss the concept of block diagram reduction and the necessity of block diagram reduction, the rules for the reduction, some examples and the references. So first, what is a block diagram reduction? Actually, a system consists of a number of components. The function of each component is represented by a block, and all the blocks are interconnected with each other. And hence, a block diagram gives an overall idea of the interrelationship that exists among the various components of the system. And actually, it is a pictorial representation. We use the reducing multiple blocks into a single block, and for the to find out the transfer function, it is very much required to find out the block diagram reduction. So here we have considered a system, and this is the block diagram of a system whose transfer function is given as the GS. The input of the system is denoted as RS, and the output of the system is denoted as the CS. Now, the block describes the relationship between the input and the output quantities through this transfer function. That means this RS is going to the input of the GS and it produces the output CS. So, this CS by RS relationship can be obtained by this block diagram representation. Now, a single block may represent an overall system or only a single component of the complex system, depending on the detail desired. Now, set of equations describing the behavior of the system can be written with each term in the equation can be represented by the block. And these blocks can be interconnected in a manner directed by the equations and the equations solved by manipulating the block diagram. And then it conveys the arrows, and it arrows actually shows that the flow of the signals are the unidirectional. That means generally it flows from source to the output. So these are the present ingredients of the transfer block diagram. That is the functional block. Here GS is acting as the functional block. Next is the summing point. Now, summing point is a point in a system where two or more signals are algebraically added or the difference of the signals can be taken. Here, the RS is the positive sign and CS is the negative sign. So, the output ES is the algebraic difference between RS and CS. That means ES is equal to RS minus CS. If this sign is positive, then ES will be the algebraic sum of RS and CS. That means ES will be RS plus CS. And the last one is the takeoff point. A takeoff point or the pickoff point is a point in a system from which the output signal from a block goes concurrently to the other blocks or the summing points. So here this point is used as the takeoff point. And we can say that the takeoff point from the input signal does not alter the input signal. The input variables may proceed unaltered to several different paths. That is, a takeoff point distributes the input signal and diminishes to the several points. Next is the rules of reduction techniques. So first consider two blocks G1 and G2 is connected in series or cascaded connection. Cascaded means the output of the first block is used as the input of the second block, and the first block input is RS and the final output is CS. So if the cascade block with transfer function G1 and G2 is there, then it can be replaced by transfer function with a single block equal to the convolution of two transfer function of each block. So the CS by RS will be G1 into G2. Now how it can be possible? So for the first block G1, the output is XS. So we can write RS into this G1, that is equal to XS. And for the block 2, that is for G2, CS is equal to XS into G2. Now we have to find out the overall transfer function, that is CS divided by RS. So this CS divided by RS can be written as CS by XS into XS by RS. Now CS by XS is equal to G2 and XS by RS equal to G1. So the overall transfer function CS by RS is equal to the convolution of individual transfer functions G1 and G2. So when two blocks are in series, then we can reduce this block by a single block with transfer function equal to the convolution of the each block. Next is the parallel connection of blocks. So here G1 and G2 are connected parallelly, and in this summing point both the signals are positive. That means output of this is the summation of X1s and X2s, and RS is the single input that goes to the G1 block and same input is going to the G2 block. Now the parallel blocks with G1 and G2 can be replaced by a single block with transfer function equal to the sum of the individual transfer function of the blocks. For this G1 block, we can say that RS into G1, that is equal to X1s, and for the G2 block, we can say RS into G2, that is equal to X2s, and the total output CS equal to X1s plus X2s. Now we can put the values of X1s and X2s from these two equations, and then we can find out the overall transfer function CS by RS is equal to G1 plus G2. That means for the parallel connection, the single block will have transfer function equal to the sum of the transfer function of individual blocks. The next rule is the shifting of takeoff point. Now the shifting of takeoff point can be done into two directions, either in the direction of the signal flow, and in the whole system we are considering that signal is flowing from the source to the output section. So hence there will be 2 points. One is takeoff point is shifting to the direction of the signal flow, and another will be shifting of takeoff points to the opposite of the direction of the signal flow. So first consider the when takeoff point is shifted to the direction of the signal flow. So here this is a block G1. So input is RS and output is CS, and takeoff point is located at before the G1 block. That means we are taking the RS signal as the output of this takeoff branch. Now this takeoff point has been shifted to the right of the block. That means it has been shifted here. So if it has been shifted here, then we are actually taking the output from the CS part. So the output becomes CS, but if we need to keep the output as the RS, then we have to divide the takeoff branch by the block transfer function. So if a takeoff point is shifted to the direction of the signal flow, then the takeoff branch has been divided by the block transfer function. And next is the shifting of takeoff point to the opposite of the direction of signal flow. So here actually we are taking the takeoff point from the output section. That means output of this section is CS. But when it shifts to the left of the block, then normally it will have the output CS RS, but to keep the output same as CS, we need to multiply it with the transfer function of the block G1. That means to shift the takeoff point to the opposite of the signal flow or to the left of the block, then multiply the takeoff branch by the block transfer function GS or G1. And the next is the shifting of summing point. Now, summing point is actually a point which output is the algebraic sum or difference of two or more three different inputs. So here we are considering x1s and x2s are two different inputs, and that output goes to the block G1 and it will produce an output CS. Now here the CS is equal to actually the x1s plus x2s, because this signal, the output of this summing point is summation of these two, that means x1s plus x2s, and that is connected to G1. So whole into G1 is equal to CS. Now this summing point has been shifted over here. So if it has been shifted over here, now the CS becomes x1 G1s plus only x2s. So to make the CS same, we have to multiply the branch, that is by the G1s. So to shift the summing point to the right of the block or to the direction of the signal flow, we have to multiply the signal entering the summing point by the block transfer function G1. And the next point is to shift the summing point opposite to the direction of the signal flow. So first it is located at here, and next we have to shift the summing point to the previous of this block, that is the opposite direction of signal flow. So in this case the CS is actually G1s G1 into x1s plus x2s, because x1s is connecting to G1. So summing point output CS is equal to x2s plus G1 into x1s. Now if the summing point has been shifted to this location, it becomes like this. So to make this output same, then we have to multiply it by 1 by G1s. That means to shift the summing point to the left of the block or to the opposite of the signal flow, then we have to divide it by the block transfer function G1. So two things we have to keep in mind, that for shifting of summing point to the direction of the flow, we are multiplying, and for opposite shifting of the direction of the flow, then we are dividing the branch. And for the takeoff point, to shift the takeoff point to the direction of the flow, we are dividing the branch by the block transfer function, and to shift the takeoff point to the opposite of the signal flow, then multiply the takeoff branch by the block transfer function. That means these two are opposite. Next is elimination of feedback. So here the forward path transfer function is GS, and GS is known as OLTF, that is open loop transfer function. RS is the input, CS is the output, and HS is the feedback. And the summing point output is ES, and ES is the algebraic difference between the incoming signals, that is RS minus CS into HS. So that's why ES equal to RS minus CS into HS, and also ES into GS, that is equal to CS. And using these two equations, we can write CS by GS equal to ES, and that is equal to RS minus CSHS. From this equation, we can find out the closed loop transfer function, that is the output CS divided by input RS, and that is equal to GS by 1 plus GSHS. So this is the closed loop transfer function, where the open loop transfer function is GS. Now we have to keep in mind that if this signal is minus over here, then the overall transfer function will be GS by 1 plus GSHS. And if this sign is plus, then the closed loop transfer function will be GS by 1 minus GSHS. And the next one is the interchanging of summing points. So here, first summing point, the inputs are RS and X1s, and the output of the first summing point is the input of the second summing point, and second summing point, the another input is XS. So overall CS is equal to summation of RS plus X1s plus this XS. Now these two summing points can be interchanged. That means for the first summing point 1, first it is input is RS and then XS, then the output of this first summing point goes to the second summing point, and the x1 is connected to the second summing point. So here also the CS is equal to summation of Rs plus Xs plus X1s. So from this we can say that interchanging of summing points will not hamper the output. Next, let us see some examples of block diagram reduction. Now, we have to find out the transfer function of the given block diagram. So, in this section, Rs is connected to the summing point, two blocks are then connected, and one feedback is there, and final output is Cs. So, now it is a pictorial representation, and we can solve it by step-by-step methods. So, first consider the first step. Now, G1 and G2, these are connected in series connection because the output of the block G1 is used as the input of the block G2. So, G1 and G2 is connected in series. So, we have to write G1 and G2 in a single block that is represented by G1, G2. Next is H1. Now, H1 is the feedback. One thing you have to keep in mind that when two signals are flowing opposite to each other, then they are acting as a feedback, and if the signals have the same direction, then it will be the parallel paths. Now, the main signal is flowing from Rs to Cs, and for H1 the signal has the opposite direction, so H1 is the feedback, and in this summing point the sign is plus, so this is considered as a positive feedback. Next step, we have to eliminate this positive feedback by using the formula Gs by 1 minus GSHs. So for this one, the forward path transfer function is G1, G2 by 1 minus the forward path transfer function is G1, G2 into the feedback H1. So the overall transfer function Cs by Rs is equal to G1, G2 by 1 minus G1, G2 into H1. Next, consider another example. So here different type of blocks are there, and G3 is going to the summing point this, and this summing point 2. So first check the G2 and G3. This signal from G2 is from Rs to Cs, as well as for the G3 it has the same direction. That means G2 and G3 are parallel, as well as the G3 and G4 are parallel. So we are eliminating G3 and G4 and G2 and G3. So by eliminating, so G2 plus it becomes G2 and G3 becomes G2 plus G3 because these two are in parallel, as well as G3 and G4 becomes G3 plus G4 because these two are also parallel. Then next the G5 block is there, and when the operation has been done, there is no function of this summing point as well as this summing point. So I have removed these two summing points also. Now we have to shift this takeoff point to the left of the block. For the shifting of the left of the block, then we have to multiply this by the block transfer function. So it becomes G1 into G2 plus G3. And then we can see that G2 plus G3 is series with the G5. And there is another negative feedback, that is G6, and this line, and it has been marked here that G6 and this line, when no other gain is written over here, then we have to consider this as 1. So one negative feedback is connected to this, and with this series connection, G3 and G4 is in parallel connection with these two. So go to the next step. For the next step, it becomes the 1 by 1 plus G1 into G2 plus G3 because it was the negative feedback elimination, and forward path transfer function was 1 divided by the GS is 1, and for negative feedback it is 1 plus this feedback element. So it becomes 1 by 1 plus this one. So this one, and for the next G5 is series with G2 plus G3. So G5 will multiply it with this combination, So look at this. This is G5 is multiplied with this one, and G3 and G4 are in parallel connection with this block. And next here we are also removing the negative feedback, that is G6 by 1 plus G6. Now these individual blocks are in series. So adding these two in parallel, so it is the summation output will be the sum of this one with this one, that is G5 into G2 plus G3 minus, because though it is parallel, still it has minus sign over here, so minus G3 minus G4. And all these individual blocks are in series connection. So in the next step, that is step 5, we are multiplying all these three block transfer functions like this, and then the G7 is used as the positive feedback. So we have applied this formula, forward path transfer function divided by 1 minus the forward path transfer function into the feedback, and then find out the overall transfer function. Let us see another example where there are two inputs are there, that is disturbance input is present. So we have considered that these systems are linear time invariant system, and it is a linear system, that means it obeys the superposition principle. And for superposition principle, if one input is absent in any time, then we have to find out the transfer function, and for the latter on, then another input is acting alone, and we have to find out the another transfer function, and the overall transfer function will be summation of the both transfer functions when one individual input is present only. So here we have first considered that only Rs is acting alone and Ds is 0. So when Ds is 0, then it becomes like this. Rs is present, that goes to G1, and G2 and H, these are in the negative feedback. Then we have eliminated this negative feedback like this, G1 into G2, because G1 is in series combination with this two. So this section becomes G2 by 1 plus G2 into H, and G1 is in series with that. So G1 is multiplied with this. Then the feedback is there. So for this one, Cs by Rs, that will be the forward path transfer function G1 G2 by 1 plus G2 into H whole divided by 1 plus this. So the transfer function 1, that represents the Rs is acting alone, and the transfer function 1 becomes G1 G2 by 1 plus G1 G2 plus G2 into H. And for the next, we have considered that Ds is acting alone and Rs is not present, and for this diagram we have to look from Ds to Cs. So Ds is connected here and Cs, then G2 block is present in between Ds and Cs, and this H and the G1 becomes the feedback. Now here H is connected to this summing point with minus sign, that means H is negative feedback, but this one is the minus sign, Rs is 0. So this is equal to minus of 1, and minus 1 is multiplied with G1, and then we are adding it as a plus. So it is actually, it will be the minus sign with G1 transfer function. And then these two are parallel blocks. So eliminating these two by a single block, and that becomes H plus G1. Now we have to eliminate this negative feedback, that will be G2 divided by 1 plus G2 into H plus G1. And then this one is the transfer function when Ds is acting alone and Rs is 0. And the overall transfer function is the summation of this first transfer function G1 G2 by 1 plus G1 G2 plus G2H plus the G2 divided by 1 plus CH2 plus G1 into G2. So in these cases where two type of inputs are there, one is normal input, another is disturbance input, we have to find out the transfer function with one input is acting alone consideration, and then the another one, and the overall transfer function will be summation of these two transfer functions according to the superposition principle. And these are my references. Thank you.